What if everything we think we know about the history of science is missing crucial chapters? Hidden in the dust of ancient ruins and the shadows of forgotten temples lie objects so advanced, so baffling, that they force us to question the very timeline of human innovation. These aren't just artifacts, they're enigmas that defy explanation, machines that seem to leap centuries ahead of their time, and devices that whisper secrets about knowledge lost to the ages. Today, we're not just exploring history, we're stepping into a mystery that could rewrite the rules of physics itself. Picture this: 2,000 years ago, a Greek sailor turns a bronze dial, and the positions of the planets align perfectly with the gears of a handheld device. Half a world away, a clay jar hums with a faint electric current, while on another continent, a crystal lens focuses sunlight into a beam precise enough to engrave metal. These aren't scenes from a fantasy novel, they're glimpses of real technologies that ancient civilizations left behind, technologies that shouldn't exist according to our textbooks. How did they achieve such feats without blueprints, without modern tools, without the scientific principles we take for granted? The answers might lie in 24 extraordinary relics scattered across time and space, each one a puzzle waiting to be solved. This isn't just a story about the past, it's a challenge to our present. Every one of these devices carries a question that shakes the foundations of what we believe possible. Could the ancient Greeks have built the world's first computer? Did the Egyptians harness electricity centuries before Edison? Why did some of these inventions vanish for millennia, only to be rediscovered in fragments? As we unravel these mysteries together, you'll see history not as a straight line of progress, but as a web of brilliance, dead ends, and forgotten breakthroughs. By the end of this journey, you won't just see these artifacts as curiosities. You'll see them as clues that hint at a past far more sophisticated, far more daring than we've ever imagined. So let's begin, because the deeper we dig, the more the past starts to look like the future. Buried beneath the waves for over 2,000 years, the Antikythera Mechanism wasn't just another artifact, it was a time capsule of ancient genius. When sponge divers stumbled upon it in 1901 off the coast of a small Greek island, no one could have guessed that this corroded lump of bronze would upend our understanding of history. At first glance, it looked like a piece of shipwreck debris, but as layers of marine incrustation were carefully removed, an astonishing truth emerged. This wasn't just a relic, it was a machine of staggering complexity, with interlocking gears and precision-cut dials that mirrored the movements of the cosmos. The mechanism's purpose: to predict celestial events with uncanny accuracy. It could track the positions of the sun, moon, and planets, forecast eclipses, and even account for irregularities in the moon's orbit, a feat requiring knowledge of astronomy and mechanics that historians once thought impossible for its time. The device was so advanced that nothing comparable would appear again until the astronomical clocks of medieval Europe, more than 1,000 years later. How did the ancient Greeks, without modern tools or the precision of industrial manufacturing, create something so intricate? One theory points to the legendary intellect of Archimedes, who reportedly designed similar devices. Ancient texts describe celestial globes and mechanical wonders built by him, though none survived until now. The Antikythera Mechanism's gear ratios match descriptions of his work, suggesting this might be a descendant of his designs. But even if Archimedes inspired it, the craftsmanship raises deeper questions. The gears were cut by hand, their teeth spaced with a precision rivaling 19th century clockmaking. The device even accounted for the elliptical orbits of celestial bodies, a concept formalized by Johannes Kepler in the 17th century. Perhaps most tantalizing is what the mechanism implies about lost knowledge. It wasn't just a lone marvel. Inscriptions on its casing reference other, now vanished devices. Was this part of a broader tradition of ancient engineering, one that vanished with the decline of classical civilization? The Roman shipwreck where it was found carried luxury goods from across the Mediterranean, hinting that such mechanisms might have been more widespread than we think. Modern technology has peeled back the layers of this puzzle. High-resolution X-rays and three-dimensional imaging revealed hidden inscriptions and gear functions, allowing scientists to reconstruct how it worked. Yet every answer brings new questions. Who used it? Was it a teaching tool, a navigational aid, or something more ritualistic? And most hauntingly, how much more did the ancients know that we've yet to rediscover? The Antikythera Mechanism doesn't just challenge our timeline of technology, it whispers of an entire chapter of human ingenuity waiting to be read. In the dusty ruins of a 2,000-year-old Mesopotamian village, archaeologists uncovered something that shouldn't have existed: a cluster of peculiar clay jars, each about the size of a fist, sealed with asphalt and containing an iron rod encased in a copper cylinder. At first glance, they seemed like simple storage vessels, but when researchers peered inside, the truth was far more shocking. These weren't just containers, they were power sources. Now known as the Baghdad Batteries, these unassuming artifacts might be the earliest evidence of human mastery over electricity, predating the modern battery by millennia. The design is deceptively simple. Fill the jar with an acidic liquid like vinegar or grape juice, and the chemical reaction between the copper and iron generates a small electric current, roughly 1 volt, enough to produce a faint tingling sensation. Replicas built using the same materials and methods have proven it works, sparking a heated debate among historians. Was this accidental chemistry, or did ancient Mesopotamians intentionally harness electricity? One compelling theory suggests these batteries were used for electroplating, coating objects with thin layers of gold or silver. Nearby artifacts from the same era show intricate gilding that matches the results of modern electroplating experiments using the jars. Imagine a craftsman in ancient Babylon dipping a figurine into a solution, connecting it to one of these cells, and watching as precious metal particles mysteriously bond to its surface. To an observer at the time, it would have seemed like magic, but if true, it means the fundamental principles of electrochemistry were understood centuries before Alessandro Volta invented the first official battery in 1800. Another possibility lies in the realm of medicine. Ancient texts from Egypt and Greece describe treatments for pain using electric fish, suggesting early awareness of electricity's physiological effects. Could the Baghdad batteries have served a similar purpose? A gentle shock from one of these devices might have been used to numb aches or even stimulate healing, an ancient form of electrotherapy. Without written records, we can only speculate, but the potential applications are as intriguing as they are varied. Skeptics argue the jars could have held sacred scrolls or been used for storage, with the metal components serving a purely ritualistic function. Yet the presence of asphalt, a known insulator, hints at deliberate engineering to prevent short circuits. The truth may never be fully uncovered, but one thing is certain: the Baghdad batteries challenge our assumptions about the timeline of scientific discovery. If these were indeed primitive batteries, what other electrical experiments might have been lost to time? The spark of ancient innovation still flickers in these clay jars, waiting to illuminate the shadows of history. Deep in the shadowed corridors of Egypt's Dendera temple, A series of carvings stretch across the stone walls, telling stories of gods and pharaohs. But one image stands out, not for its divine subject, but for its uncanny resemblance to a technology that wouldn't be invented for millennia. It shows a large, elongated object resembling a glass bulb with a snake-like filament coiled inside, supported by a pillar and connected to what looks like a cable or cord. To modern eyes, it's impossible not to see the silhouette of an electric light bulb. And that's where the mystery begins. Mainstream Egyptologists interpret the carving as a symbolic representation of a lotus flower cradling a snake, tied to the myth of the sun god Ra emerging from a cosmic egg. But the parallels to 20th century lighting technology are startling. The bulb even tapers at the base, much like the screw thread of a modern bulb, while the filament mirrors the glowing wire inside an incandescent lamp. Could this be coincidence or evidence of a lost electrical tradition? Proponents of the ancient technology theory point to the absence of soot marks in certain Egyptian underground chambers, like the crypts beneath Denderer, where torches or oil lamps would have left traces. How did they illuminate these spaces to create their intricate carvings? The temple walls themselves offer no answers, but the sheer precision of the artwork suggests the artisans worked with exceptional clarity. Some experiments have shown that replicas of the Denderer design, using gold leaf filaments and acidic solutions, can produce a faint glow, hinting at a possible electrochemical lighting method. Yet skepticism remains. Without physical remnants of bulbs or wiring, the case rests on interpretation. The temple's full context includes other symbolic imagery, like the god Harsamtus being born from the bulb, reinforcing the religious narrative. Even the cable might depict a ceremonial rope common in Egyptian iconography. But the lingering question is this: if it's purely symbolic, why does it align so precisely with a technology the ancient world supposedly never knew? The debate reflects a broader tension in archaeology: how to weigh intuitive leaps against conservative analysis. For every researcher who sees the Dendera Light as proof of forgotten innovation, another cautions against projecting modern ideas onto the past. But perhaps the truth lies in the middle. Could the Egyptians have stumbled upon a primitive form of lighting, later mythologized in their art? Or does the carving simply reveal how advanced their symbolic thinking was, crafting metaphors so universal they echo across time? The walls of Denderer keep their secrets, but the light of curiosity continues to shine. Scattered across the ruins of Roman Britain, Gaul, and Germania, these peculiar bronze objects defy categorization. Each one is a hollow dodecahedron, a 12-sided geometric marvel ranging in size from a golf ball to a baseball, with circular holes of varying diameters on every face and knobs at each corner. Over 100 have been unearthed, yet not a single shred of written record from antiquity mentions their purpose. The Romans documented everything from plumbing to poetry, but these enigmatic artifacts received not one passing reference. Their silence is as deliberate as the object's construction, and that's what makes them so tantalizing. The craftsmanship alone tells a story. Cast in bronze with meticulous symmetry, their surfaces often show no signs of wear, suggesting they weren't everyday tools. Some theories paint them as astronomical devices, their holes aligned to track celestial events or measure the angle of sunlight for planting crops. Yet no two dodecahedrons share identical hole sizes, undermining the idea of standardized calculations. Others propose they were knitting tools for gloves, with the knobs anchoring yarn. But why fashion something so complex when simple wooden rings would suffice? Then there's the spiritual angle. Several were found in burial sites or near temples, hinting at ritual use. The 12 faces might symbolize the zodiac, or the holes could channel incense smoke during ceremonies. One particularly ornate specimen discovered in Switzerland features intricate markings resembling lunar cycles, fueling speculation about sacred calendars. But without context, these interpretations remain as hollow as the objects themselves. Modern attempts to decode their function range from the pragmatic to the poetic. Engineers suggest they might have been calibration devices for military surveyors, while hobbyists insist they're ancient dice for elaborate games. One experiment demonstrated that when threaded with leather straps, they form a sturdy frame for measuring distances, a sort of Roman rangefinder. Yet none of these explanations fully account for their widespread distribution or the absence of written clues. Perhaps the most intriguing clue lies in their geographic spread. Most were found in the empire's northern provinces, far from Rome's heartland. This regional concentration suggests they served a purpose unique to these frontier cultures, possibly blending Roman engineering with local traditions. Could they have been diplomatic gifts, their meaning lost when the cultures that valued them faded? Or were they teaching tools, physical aids for demonstrating geometric principles to students? The dodecahedrons resist easy answers, and that's their power. They remind us that history isn't a puzzle to be solved, but a conversation to be joined. Every new discovery, a dodecahedron nestled in a farmer's field, another unearthed during road construction, adds another whisper to the dialogue. For now, they stand as bronze metaphors for the limits of our knowledge, inviting us to marvel not just at what the Romans achieved, but at how much remains just beyond our grasp. Buried beneath the ruins of the Minoan palace of Phaistos, this circular clay tablet doesn't look like much at first, just a palm-sized disc, baked hard in a fire long ago. But turn it over, and you're met with a sight that has baffled linguists for over a century: spiraling coils of strange symbols pressed into the clay with meticulous precision. 45 distinct characters, from human figures to birds, shields, and abstract shapes, repeat in sequences that seem anything but random. Yet despite countless attempts, no one has ever cracked its code. The Phaistos Disc isn't just an unsolved puzzle, it's a linguistic island, utterly alone in the archaeological record. What makes this artifact so maddening is its singularity. Unlike Egyptian hieroglyphs or Mesopotamian cuneiform, which were decoded using bilingual texts like the Rosetta Stone, the Phaistos Disc has no parallels. Its symbols weren't carved or painted but stamped into wet clay with individual seals, making it the earliest known example of movable type printing, a technology that wouldn't reappear for another 3,000 years. Why would this method vanish for millennia, only to be reinvented in 15th century Europe? And why was it used for just this one mysterious object? Theories about its purpose range from the practical to the profound. Some argue it's a ledger, recording goods or taxes in a system lost to time. Others see it as a religious hymn or a guide to sacred rituals, its spiral perhaps mirroring the labyrinth of nearby Knossos. More tantalizing are claims that it encodes advanced knowledge, mathematical concepts, astronomical charts, or even early physics principles. A few researchers note that certain symbol sequences repeat in ways resembling later Greek musical notation, suggesting it could be a compositional score. But without a key, these remain speculative leaps. Modern technology has only deepened the mystery. High-resolution scans reveal subtle details in the stamping, confirming the disc wasn't a trial piece but a finished product. Statistical analyses of the symbols show patterns consistent with language, yet attempts to link it to known scripts, Linear A, Egyptian, even ancient Anatolian, have all failed. The closest match might lie in the undeciphered symbols found on a single axe from Archimedes, but with just a handful of characters, it's hardly a Rosetta Stone. Perhaps the most haunting question isn't what the disc says, but why it exists at all. Was it a diplomatic message from a lost civilization? A lone scribe's experimental prototype, or something far more personal, a prayer, a poem, a love letter pressed into clay by someone who never imagined their words would outlive them by millennia? The Phaistos Disc refuses to give up its secrets, but in that refusal, it offers something else. A reminder that history isn't just about the answers we find, but the questions that keep us searching. Among the treasures unearthed in 1898 from a tomb near Egypt's Saqqara necropolis, one artifact stands out not for its gold or jewels, but for its startlingly modern shape. Carved from sycamore wood and dating back to around 200 BCE, the Saqqara Bird measures just over 5 inches long, with a sleek fuselage, angled wings, and a distinct tail fin, a silhouette that wouldn't look out of place in a 20th century aviation museum. At first, archaeologists catalogued it as a stylized bird figurine, a common funerary offering. But when aviation experts examined its design centuries later, they noticed something extraordinary. The proportions of its wings and the angle of its tail match the aerodynamics of a glider. To test the theory, engineers built scaled-up replicas using the same dimensions. When launched, the models achieved stable, extended flights, proof that the design wasn't just decorative but functionally sound. The tail's vertical stabilizer, a feature absent in natural birds but critical for aircraft, prevents sideways drift while the wing's curvature generates lift. These aren't accidental traits, they're deliberate engineering choices. So how did ancient Egyptians, who left no records of flight experiments, seemingly grasp principles that wouldn't be formalized until the age of Da Vinci? Skeptics argue the bird's resemblance to aircraft is coincidental, pointing to similar wooden carvings of falcons found nearby. Yet none of those artifacts share the Saqqara bird's precise aerodynamic features. Another theory suggests it might have been a ceremonial throw stick or even a wind vane, but neither explanation accounts for its balanced flight performance. The most provocative possibility, that it's a scaled-down model of a larger man-carrying glider, a concept hinted at in obscure texts describing winged contraptions used in religious ceremonies. The mystery deepens when considering Egypt's broader technological context. Their mastery of geometry and physics is evident in pyramid construction, and they documented detailed observations of bird flight. Could temple artisans have experimented with flight as an extension of their reverence for avian deities? Without blueprints or written accounts, we're left with tantalizing silence. What makes the Saqqara Bird so compelling isn't just its potential to rewrite aviation history, it's the way it blurs the line between ritual and innovation. Whether a sacred object, a toy, or the remnant of a lost experiment, it soars beyond easy categorization, reminding us that ancient minds might have reached for the skies long before we ever imagined. Buried in the ruins of an Assyrian palace in Nimrud, this small piece of rock crystal seemed insignificant at first until someone held it up to the light. Dating back to 750 BCE, the Nimrud Lens is a palm-sized oval, ground and polished with such precision that it can magnify objects up to 3 times their size. For over a century since its discovery, scholars have debated its purpose. Was it a magnifying tool for artisans, a navigational aid for astronomers, or even an early attempt at a microscope? The implications are staggering. A society flourishing nearly 3,000 years ago may have understood optical principles centuries before the scientific revolution formalized them. The lens itself is a marvel of craftsmanship, made from natural rock crystal. Its slightly oval shape and carefully calculated curvature suggest deliberate design rather than accidental formation. Microscopic analysis reveals fine grinding marks, indicating it was shaped by hand. a painstaking process requiring knowledge of how light bends through materials. Assyrian artisans were renowned for their intricate ivory carvings and seal engravings, some featuring details smaller than a millimeter. Could the lens have been their secret tool, allowing them to work with such precision? But its potential uses stretch far beyond craftsmanship. Ancient Assyria was a powerhouse of astronomy, with scholars meticulously tracking planetary movements. Could the lens have been part of an observational device, enhancing the naked eye's view of the stars? Some speculate it might have been mounted in a primitive telescope, though no such apparatus has been found. Others propose a more practical function, as a burning lens, focusing sunlight to start fires or cauterize wounds, a technique described in later Greek texts. The most tantalizing theory, however, ties the lens to medicine. Assyrian medical texts describe eye diseases in detail, and the lens's magnification could have aided early surgical procedures. Imagine a healer in Nineveh using this crystal to examine wounds or remove tiny splinters, pushing the boundaries of what was thought medically possible at the time. Yet skeptics argue it might have been purely decorative, a piece of jewelry or a ceremonial object. After all, rock crystal was prized for its clarity and beauty. But the lens's optical properties are undeniable, raising the question: even if its primary purpose was ornamental, did its users recognize its magnifying potential? The line between utility and artistry in antiquity was often blurred. What makes the Nimrud Lens so compelling isn't just its function, but what it represents: a glimpse into a world where experimentation and observation weren't confined to textbooks but emerged organically from daily needs. Whether used by a jeweler, an astronomer, or a physician, this small crystal shard challenges our assumptions about the pace of scientific progress. It's a reminder that curiosity and ingenuity are timeless, and that the quest to see farther, whether into the stars or the microscopic world, has always been part of the human story. Hidden away in a vault at Yale University lies a book unlike any other, a tome so enigmatic that it has resisted every attempt at deciphering for over 6 centuries. Known as the Voynich Manuscript, this 240-page parchment volume is a labyrinth of looping, alien script and surreal illustrations that seem to defy logic. Plants with impossible roots, nude women bathing in emerald green pools, celestial charts mapping unknown constellations. Each page is a window into a world that makes no sense to modern eyes. Carbon dated to the early 15th century, its vellum pages hold secrets that have stumped cryptographers, linguists, and even wartime codebreakers. What makes this manuscript so utterly uncrackable, and why, after 600 years, does it still guard its mysteries so fiercely? The text itself is the first puzzle. Written left to right in an alphabet of 20 to 30 unique characters, the script flows with the rhythm of a natural language, yet no one has ever identified its roots. Statistical analyses reveal patterns consistent with real linguistics, like word repetition and sentence structure, but attempts to link it to known languages, from medieval Latin to extinct Ukrainian dialects, have all failed. Even the infamous World War II codebreakers who cracked the Nazi Enigma machine threw up their hands when confronted with the Voynich. Some researchers claim to have found fragments of meaning, a word here, a botanical label there, but no consensus has ever emerged. The writing remains as inscrutable as the day it was discovered. Then there are the illustrations, which only deepen the confusion. The manuscript is divided into sections, each with its own bizarre theme. Herbal pages showcase plants that don't match any known species, their leaves and flowers twisting into impossible hybrids. Astronomical diagrams depict spiral formations of stars unlike any medieval cosmology, while biological sections show tiny, interconnected tubes and vessels reminiscent of cellular structures or alchemical diagrams. Most haunting are the so-called nymph pages, rows of plump, naked women submerged in what might be fluids or energy streams, their purpose utterly opaque. Are these medical treatises, allegorical visions, or something else entirely? Theories about the manuscript's origins span the spectrum from scholarly to sensational. Some argue it's a coded scientific text, possibly containing lost alchemical formulas or early physics experiments. The herbal sections might document unknown pharmacological techniques, while the celestial pages could hint at unconventional astronomical observations. Others believe it's a hoax, an elaborate medieval forgery designed to dupe a wealthy patron. Yet the complexity of the script and the consistency of its patterns suggest it's anything but random gibberish. More tantalizing is the idea that it represents a constructed language or an extinct tongue, its meaning lost when its last speaker died. Modern technology has only added layers to the mystery. Multispectral imaging has revealed faint traces of earlier writing beneath some pages, hinting at palimpsests erased and reused. Artificial intelligence analyzers have tentatively linked the script structure to Old Turkic or Semitic languages, but these remain speculative. Even the book's provenance is murky. It resurfaces in history only in the 17th century, when an alchemist claimed it was the work of the 13th century scholar Roger Bacon. What makes the Voynich Manuscript so compelling isn't just its indecipherability, it's the way it mirrors the limits of human knowledge. Here is a book that was clearly important enough for someone to painstakingly craft, yet its purpose has evaporated into time. It challenges our arrogance, reminding us that history isn't a puzzle to be solved, but a conversation where some voices speak in tongues we may never understand. Every failed attempt to crack its code is a humbling lesson. Some secrets, it seems, are meant to stay secrets. Imagine a weapon so terrifying that enemies would leap into the sea to escape it, only to find the flames followed them into the water. This was the nightmare faced by anyone who dared challenge Byzantine ships armed with Greek fire, a liquid inferno that defied the basic laws of nature. First unleashed in the 7th century, this incendiary marvel became the empire's most closely guarded secret, a technological edge that kept Constantinople unconquered for nearly 800 years. The recipe was so valuable that emperors reportedly engraved it in gold and locked it away in vaults, with death as the penalty for revealing it. Today, despite centuries of speculation, its exact formula remains one of history's most tantalizing mysteries. The weapon's tactical brilliance lay in its simplicity and horror. Launched through bronze tubes mounted on ships, the sticky liquid would cling to enemy vessels and even burn atop waves, creating walls of fire that couldn't be doused with water. In fact, some accounts suggest water intensified the flames. Historical records describe Arab fleets dissolving into panic as their sails ignited, and their oarsmen scrambled in vain to escape the creeping fire. The psychological impact was as devastating as the physical damage. Entire armies reportedly retreated at the mere sight of Byzantine ships approaching, fearing the unquenchable flames. Modern chemists have pieced together plausible ingredients based on fragmentary texts and the weapon's behavior. The base likely included crude petroleum or naphtha, distilled into a volatile, adhesive gel. Quicklime, a substance that reacts violently with water, could explain its ability to ignite on contact with the sea. Some theories propose additives like sulfur or saltpeter to intensify combustion, while others point to pine resin or wax for thickening the mixture into a clinging napalm-like substance. Yet no reconstruction fully matches the historical descriptions of Greek fire's relentless burn and eerie resistance to extinction. What makes this weapon so revolutionary wasn't just its chemistry, it was its delivery system. The Byzantines engineered pressurized bronze siphons, possibly using early pump mechanisms, to spray the liquid in continuous streams. This wasn't just hurling fire. It was precision-engineered warfare, combining fluid dynamics, metallurgy, and pyrotechnics in a way that wouldn't be seen again until modern flamethrowers. The siphons themselves were state secrets, with craftsmen sworn to silence under penalty of mutilation or execution. The legacy of Greek fire stretches beyond the battlefield. Its existence hints at a sophisticated understanding of chemical engineering lost to time. Byzantine alchemists may have stumbled upon principles of distillation and catalysis centuries before they were formally documented. Some scholars even speculate that the weapon's development was tied to earlier experiments by Alexandrian scientists, whose texts on pneumatics and hydraulics survived in Byzantine libraries. Yet for all its power, Greek fire couldn't save the empire forever. By the 15th century, the secret had faded, whether lost to time, suppressed by rivals, or rendered obsolete by gunpowder. The last recorded use was during Constantinople's final siege in 1453, when desperate defenders reportedly unleashed remnants of the ancient weapon against Ottoman forces. Its fleeting reappearance was a ghostly echo of a technology that once defined an era. Today, Greek fire stands as a symbol of how innovation and secrecy intertwine. It wasn't just a weapon, it was a psychological masterpiece, a tool of deterrence that shaped geopolitics for centuries. Its disappearance reminds us that even the most advanced knowledge is fragile, vulnerable to the erosion of time and the silence of forgotten vaults. The flames may have died, but the questions they ignite about lost science burn as brightly as ever. In the year 132, while much of the world still attributed earthquakes to the whims of gods or mythical beasts, a brilliant Chinese scientist named Zhang Heng unveiled something extraordinary, a bronze vessel so advanced it could detect earthquakes hundreds of miles away. His seismoscope wasn't just a ceremonial object, it was a precision instrument, a masterpiece of early physics that leveraged principles modern seismologists wouldn't formalize for another 2,000 years. Shaped like an ornate urn and adorned with 8 dragons, each clutching a metal ball above a corresponding bronze toad, the device was as beautiful as it was functional. But how did it work? And more importantly, how did an inventor in ancient China grasp the mechanics of seismic waves long before the concept even had a name? The key lay in the device's hidden pendulum. When tremors rippled through the earth, the pendulum would sway, triggering a series of levers inside the vessel. These levers would release one of the dragon's balls into the mouth of the toad below, indicating not just the occurrence of an earthquake but its direction. Historical records describe an instance where the seismoscope detected a quake so distant that no one in the capital felt it. Yet days later, messengers arrived confirming a tremor in a province over 300 miles away. The precision was uncanny, suggesting Zhang Heng understood that earthquakes propagated in waves and that these waves could be measured and interpreted. What's even more remarkable is the sophistication of his design. The 8 dragons represented the cardinal and intercardinal directions, allowing the device to pinpoint a quake's origin with surprising accuracy. Some reconstructions suggest the internal mechanism might have included an inverted pendulum or even a system of counterweights to filter out minor vibrations, focusing only on significant seismic activity. This level of engineering implies a nuanced understanding of harmonic motion and resonance concepts that wouldn't be mathematically defined until the Renaissance. Yet the seismoscope's brilliance extends beyond its mechanics. It reflects a broader cultural context in which science and statecraft were deeply intertwined. Ancient China's vast bureaucracy relied on accurate record-keeping and disaster preparedness. making earthquake prediction not just a scientific curiosity, but a matter of imperial survival. Zhang Heng, a polymath who also excelled in astronomy, cartography, and poetry, epitomized this fusion of intellect and civic duty. His device wasn't created in isolation. It emerged from a society that valued empirical observation and technological innovation as tools of governance. Modern attempts to replicate the seismoscope have yielded mixed results. Some reconstructions successfully detect simulated quakes, while others struggle with the device's alleged sensitivity. Skeptics argue that historical accounts may exaggerate its capabilities, but even if the seismoscope wasn't infallible, its very existence challenges our assumptions about ancient technological limits. How many other innovations from this era were lost to time, and what might we learn if we approached history not as a linear march of progress, but as a tapestry of brilliant, isolated leaps? The legacy of Zhang Heng's seismoscope lingers not just in museums, but in the questions it forces us to ask. Did ancient China possess a proto-scientific tradition that rivaled later European achievements? Could other cultures have developed similar devices, their secrets buried beneath ruins or dissolved into folklore? The ground beneath us, it seems, doesn't just hold the remnants of earthquakes, it cradles the echoes of forgotten genius. For centuries, Viking navigators crossed thousands of miles of treacherous North Atlantic waters, without compasses, without modern charts, often under skies so overcast that neither sun nor stars were visible. How did they do it? Norse sagas speak of a mysterious tool called the Solarstein, or Sunstone, a crystal that could reveal the sun's position even through dense cloud cover. Long dismissed as myth, this legendary navigational aid is now backed by startling scientific evidence. At the heart of the mystery is a simple mineral, calcite, a transparent crystal found across Scandinavia that bends light in extraordinary ways. When light passes through calcite, it splits into two beams, a property known as birefringence. By rotating the crystal until these beams match in brightness, a navigator can pinpoint the sun's location with eerie accuracy, even when it's completely hidden behind clouds. This works because sunlight becomes polarized as it scatters through the atmosphere, creating subtle patterns invisible to the naked eye but detectable through the crystal. Modern experiments have proven the technique's effectiveness. In one study, researchers using a calcite sunstone determined the sun's position within 5 degrees of accuracy under overcast skies. That's precise enough to navigate open ocean routes between Norway, Iceland, and Greenland, the very routes Viking longships traveled 1,000 years ago. But the sunstone's brilliance goes beyond physics. It reveals a culture of observational genius where sailors combined celestial knowledge with an intimate understanding of natural materials. Viking navigators didn't rely on the crystal alone. They wove multiple techniques into a seamless web of wayfinding. They tracked wave patterns, noted the flight paths of seabirds, and used a primitive latitude calculator called a bearing dial. The sunstone was likely their secret weapon for the most challenging conditions. When fog or storm clouds erased all other clues, the archaeological record adds tantalizing hints. A calcite crystal was found aboard a 16th-century English shipwreck in the Channel Islands, preserved in a navigator's toolkit. While not Viking era, it suggests the technique survived in maritime traditions long after the Norse Age. Even more compelling is a discovery in Iceland, a piece of optical calcite buried near the ruins of a medieval Benedictine monastery, which may have preserved Viking navigation knowledge. Critics argue that without a sunstone found in a confirmed Viking context, the theory remains speculative. Yet absence of evidence isn't evidence of absence. Organic materials like wooden navigation tools rarely survive in archaeological sites. What's undeniable is that the Norse accomplished feats of navigation that defy explanation without some form of advanced technology. The Sunstone bridges the gap between legend and reality, showing how ancient innovators turned the raw materials of their environment into tools that bordered on magic. Perhaps the most profound lesson lies in the Sunstone's simplicity. In an age of GPS and satellite navigation, we've lost the art of reading the natural world's subtle cues. The Vikings remind us that cutting-edge technology doesn't always mean complexity. Sometimes it's about seeing the extraordinary in the ordinary and harnessing the hidden physics all around us. Their calcite crystal wasn't just a tool, it was a key to unlocking the invisible patterns of light itself, allowing them to sail into the unknown with nothing but a piece of the earth to guide them. The year was 212 BCE, and the fate of Syracuse hung in the balance as Roman warships closed in on the city's harbor. But according to ancient chroniclers, the legendary mathematician Archimedes had a weapon unlike anything the world had seen, a device that could harness the sun itself as a tool of war. As the ships approached, polished bronze mirrors or shields were said to focus sunlight into a single, searing beam, setting the Roman fleet ablaze from a distance. For centuries, historians dismissed the story as mere legend, a fanciful tale exaggerating the genius of antiquity's greatest mind. Yet modern experiments suggest there might be more to this ancient death ray than myth. The key lies in the physics of light concentration. When multiple flat mirrors are angled precisely, their reflected beams converge at a single point, creating temperatures high enough to ignite wood around 450 degrees Fahrenheit. In 2005, a team from MIT tested the concept using 127 mirrored tiles, successfully setting a wooden boat model aflame within minutes. A year later, a group of students in San Francisco replicated the effect with just 10 mirrored sheets, proving even modest setups could generate combustion under ideal conditions. Theoretically, with enough mirrors and skilled operators adjusting for the sun's movement, the death ray becomes plausible, but practicality raises doubts. Ancient accounts, like those of the historian Lucian, describe the mirrors as hexagonal shields mounted on a frame, a configuration that would require precise coordination under battle conditions. Wind, cloud cover, and the constant motion of ships would complicate targeting. Skeptics argue that if the weapon existed, why didn't it appear in more reliable contemporary sources, like the detailed siege accounts of Polybius? Some scholars propose an alternative interpretation. The mirrors might have been polished bronze shields used to dazzle and disorient rowers, creating a strobe-like effect rather than literal flames. Yet the story persists, partly because it aligns with Archimedes' known innovations. His work on optics, including treatises on reflection and parabolic mirrors, suggests he understood the principles needed to design such a weapon. Other inventions attributed to him, the giant claw crane that could lift and capsize ships, or the improved catapults that pummeled the Roman fleet, demonstrate his knack for applying theoretical physics to warfare. If the death ray was real, it wouldn't be an outlier but another example of his ability to turn abstract science into battlefield dominance. The debate reflects a broader tension in ancient technology studies. How do we separate fact from embellishment in texts written centuries after the events they describe? The death ray's absence from early Roman records might indicate it was a later invention, a symbolic embellishment celebrating Archimedes' intellect. Or perhaps the truth lies somewhere in between, not a single apocalyptic beam, but an array of reflective surfaces used to harass and intimidate, their psychological impact magnified over time into legend. What makes the death ray compelling isn't just its feasibility, but what it represents: humanity's enduring fascination with turning natural forces into weapons. From Greek fire to modern lasers, the dream of harnessing light as a tool of war spans millennia. Archimedes, whether he built the device or not, becomes a symbol of that ambition, a reminder that the line between genius and myth is often as shimmering and elusive as a reflection on polished bronze. In the bustling workshops of 1st century Alexandria, an inventor named Hero crafted a device so ahead of its time that it wouldn't find its true purpose for nearly 2,000 years. His eolipile, often called the world's first steam engine, was a deceptively simple contraption, a hollow metal sphere mounted on a pair of tubes, filled with water and suspended over a fire. As the water boiled, steam rushed through the tubes and escaped from angled nozzles, causing the sphere to spin with surprising force. This wasn't just a curiosity. It was a working demonstration of Newton's third law of motion. Every action has an equal and opposite reaction centuries before Newton himself would articulate it. The eolipile didn't just rotate. It whirred with the same principles that would one day propel jet engines and spacecraft. So why did this revolutionary invention vanish into obscurity, only to be rediscovered during the Industrial Revolution? The answer lies in the gap between invention and application. Hero's creation was treated as a marvel, a temple wonder to amuse audiences rather than a tool to transform labor. Ancient societies had no pressing need to mechanize production. Slave labor and manual craftsmanship filled those roles. Without an economic or social imperative to harness steam power, the eolipile remained a fascinating oddity, a toy for philosophers rather than a catalyst for industry. Contrast this with 18th century Britain, where textile manufacturers desperately sought ways to boost output, creating the perfect conditions for steam engines to flourish. Hero's world simply wasn't ready, yet the device's sophistication raises deeper questions. The precision of its construction, the carefully calibrated nozzles, the balanced rotation, suggests a mastery of fluid dynamics that rivals later engineers. Hero himself described it in his work Pneumatica, alongside other automated devices like temple doors that opened magically using heated air pressure. These weren't isolated experiments. They were part of a broader tradition of Hellenistic engineering that blended science, art, and spectacle. The eolipile might have been a dead end, but it reveals a path not taken, a glimpse of an alternate history where Antiquity's mechanical genius flowered into full-fledged industrialization. Modern reconstructions highlight just how close Hero came to something revolutionary. A well-built eolipile can reach speeds of over 1,500 revolutions per minute, generating enough force to drive small machinery. Some historians speculate that with slightly different social conditions, say, a labor shortage or a more centralized industrial economy, the ancient world might have leapfrogged into steam-powered automation. Imagine Roman factories powered by arrays of eolipiles or Alexandrian ships propelled by steam turbines. The potential was there, trapped in the amber of what if. What makes Hero's invention so haunting isn't just its unrealized potential, but the way it mirrors our own technological crossroads. How many breakthroughs today languish as curiosities because the world isn't ready to adopt them? The eolipile stands as a monument to the fragile dance between innovation and opportunity, reminding us that progress isn't just about brilliant ideas, it's about building a world willing to use them. Etched into the arid plains of southern Peru, the Nazca lines stretch across nearly 200 square miles of desert like a colossal canvas only visible from the heavens. These geoglyphs, some spanning over 1,200 feet, aren't just lines, but intricate designs of animals, plants, and geometric shapes so vast they dwarf football fields. A hummingbird with wings outstretched, a spider with legs curled as if in motion, even a figure some call the astronaut with its wide, owl-like eyes, each one carved into the earth by removing the dark surface stones to reveal the lighter sand beneath. But why would a civilization over 2,000 years ago create art they could never fully see from the ground? The answer might lie in the intersection of astronomy, religion, and something even more extraordinary. One prevailing theory suggests the line served as a celestial calendar, aligning with solstices, equinoxes, or specific star clusters. The spider, for instance, mirrors the constellation Orion, while other shapes may track the movement of the Pleiades, a star cluster central to Andean agricultural cycles. Ancient Nazca farmers, dependent on seasonal rains, could have used these alignments to predict planting and harvest times. Yet skeptics point out that not all lines correlate neatly with astronomical events, and the sheer variety of designs implies multiple purposes. Then there's the spiritual interpretation. The Nazca culture revered nature and water as sacred, and many glyphs depict animals tied to rain or fertility myths. The monkey, with its spiraling tail, might symbolize water's cyclical nature, while the killer whale, a creature from distant coasts, could represent a deity bridging land and sea. Some researchers propose the lines were pilgrimage paths, walked during rituals to invoke life-giving rains. Footwear found at the site shows signs of ceremonial wear, supporting the idea of processions. But if the lines were meant for walking, why make them so massive they're only recognizable from above? This paradox fuels the most controversial theory, that the Nazca people somehow achieved flight. Experiments with hot air balloons using materials available at the time, woven fibers and open flames, have shown it's technically possible, if risky. Could they have tethered balloons to survey their work, or did the design serve as messages to gods or celestial beings, meant to be seen from the sky? The absence of written records leaves room for speculation, but the precision of the lines achieved without modern tools or aerial views hints at sophisticated surveying techniques. Modern technology has revealed even deeper layers. Satellite imagery and drone mapping recently uncovered hundreds of previously unknown glyphs, some predating the Nazca by 1,000 years. These older designs, often humanoid figures with dramatic headdresses, suggest the tradition spanned generations, evolving in purpose. Soil studies show the line's creators may have altered the desert's microclimate, using the removed stones to trap moisture and foster plant growth, a blend of art and agriculture. What makes the Nazca lines so captivating isn't just their mystery, but what they reveal about human ingenuity. Without blueprints or written language, the Nazca transformed their landscape into a testament to their worldview, whether as a celestial clock, a sacred altar, or something beyond our current understanding. The desert still guards its secrets, but each new discovery peels back another layer, reminding us that ancient civilizations saw the world and the cosmos in ways we're only beginning to fathom. Deep in the humid jungles of Mesoamerica, the Olmec civilization thrived over 3,000 years ago, leaving behind colossal stone heads and intricate jade carvings. But among their most puzzling relics are small, carefully shaped artifacts that hint at a discovery that could rewrite scientific history. Lodestones, naturally magnetized pieces of magnetite that align with Earth's magnetic field. These unassuming stones, found at sites like San Lorenzo and La Venta, suggest the Olmecs may have unlocked the secrets of magnetism centuries before the Chinese, who are often credited with the earliest compasses. Could this ancient culture have navigated rivers or aligned sacred structures using the invisible pull of these magnetic marvels? One of the most compelling pieces of evidence comes from a polished bar-shaped lodestone discovered at San Lorenzo, its ends ground to precise angles. When suspended, it aligns roughly north-south, mirroring the behavior of a compass needle. Archaeologists also uncovered concave mirrors made of magnetite, which some believe could have been used to observe celestial movements or even manipulate light in rituals. The Olmec's obsession with orientation is evident in their city layouts. Buildings and plazas often align with astronomical events or cardinal directions with uncanny accuracy. Did they use lodestones as a primitive surveying tool, or were these objects imbued with deeper spiritual meaning? The ritual angle is equally fascinating. Magnetite's strange, seemingly magical properties, its ability to attract iron or point consistently in one direction, might have made it sacred to the Olmecs. Some artifacts were buried in ceremonial caches alongside jade figurines and serpentine masks, suggesting they held religious significance. Imagine a shaman using a lodestone in divination, interpreting its alignment as a message from the gods or a guide for sacred journeys. The line between science and spirituality in ancient cultures was often blurred, and the Olmecs may have seen magnetism as both a practical tool and a bridge to the divine. What makes this discovery so provocative is the question of independent innovation. The Chinese were using lodestone compasses for divination by the 2nd century BCE and later for navigation. But the Olmec artifacts date back to at least 1000 BC, centuries earlier. Did knowledge of magnetism arise separately in Mesoamerica, or is there a lost thread of cultural exchange we've yet to uncover? The Pacific Ocean, often seen as a barrier, was possibly navigated by ancient seafarers, though no direct evidence links Olmec and Chinese technologies. Modern experiments add fuel to the mystery. Researchers have replicated Olmec-style lodestone compasses, finding they can achieve surprising accuracy when balanced correctly. Yet without written records, we're left interpreting silent stones. The Olmec's legacy whispers of a world where natural phenomena were harnessed with ingenuity we're only beginning to recognize. Whether as navigational aids, ritual objects, or both, these lodestones pull us toward a startling possibility that the history of magnetism is far older and far more global than we ever imagined. In the dense jungles and riverbeds of Costa Rica, a mystery lies half buried in the earth. Hundreds of near-perfect stone spheres, some as small as oranges, others towering taller than a person and weighing up to 16 tons. Discovered in the 1930s when United Fruit Company workers cleared land for banana plantations, these enigmatic orbs immediately baffled archaeologists. Carved from granodiorite, a rock so hard it rivals granite, their surfaces are unnaturally smooth, their shapes so precisely spherical that modern engineers using laser measurements struggle to find imperfections. The largest specimens deviate less than 2 millimeters from perfect roundness, a feat requiring mathematical knowledge and stone-working skills that mainstream history claims didn't exist in pre-Columbian Central America. So how did ancient artisans without metal tools or written language achieve such geometric perfection? And more intriguingly, why? The sphere's origins trace back to the Diquis culture, which flourished between 700 and 1500 CE. Unlike the pyramids of Egypt or the temples of Mesopotamia, these artifacts weren't part of grand structures. They were found scattered, some in clusters, others in lines, a few isolated near riverbanks. Their arrangements have fueled theories ranging from the practical to the celestial. One grouping near the town of Pommer aligns with cardinal directions, suggesting they might have served as astronomical markers or a giant calendar tracking solstices. Others propose they demarcated tribal territories or sacred spaces, their flawless shapes symbolizing cosmic harmony. The craftsmanship involved reveals a sophistication that challenges assumptions about pre-Columbian technology. Researchers believe the Diquis used a combination of heat, water, and painstaking abrasion to shape the spheres. First, boulders were roughly fractured using fire and sudden cooling. Then, over generations, artisans would have pecked away at the stone with harder rocks, polishing the surface with sand and leather until it gleamed. The process would have taken decades for the largest spheres, an investment of labor that speaks to their immense cultural significance. What defies explanation is how they transported these mammoth stones. Some spheres were found miles from the nearest quarry, in regions without evidence of wheeled vehicles or domesticated draft animals. One theory suggests they rolled them on logs, while another posits they floated them along rivers on rafts, both risky endeavors given the sphere's weight and the terrain's ruggedness. The logistics hint at a society capable of complex communal organization, where hundreds might have collaborated to move a single sphere as part of ritual or engineering projects we can scarcely imagine. Then there's the enigma of their abrupt abandonment. When Spanish colonizers arrived in the 16th century, the spheres were already relics, their purpose forgotten by local populations. Many were looted or damaged, rolled into ravines or dynamited by treasure hunters convinced they held gold. Today, only a handful remain in their original placements, leaving archaeologists to piece together patterns from fragmentary evidence. Modern technology has peeled back some layers of the mystery. Ground-penetrating radar has revealed buried spheres untouched for centuries, while isotopic analysis traces their stone to specific quarries. Yet the deeper question lingers: were these objects functional, ceremonial, or something in between? Their silence is deafening. No carvings, no inscriptions, just mute perfection in stone. Perhaps their very simplicity is the clue. In a world without written language, the spheres might have been a universal language of form, conveying power, unity, or celestial connection across generations. What makes the stone spheres so haunting isn't just their precision, but their persistence. They've outlasted the civilization that created them, tumbling through time as riddles wrapped in rock. Every theory, from astronomical tools to symbols of political authority, only deepens the fascination. They remind us that some mysteries aren't meant to be solved, only pondered, their smooth surfaces reflecting not just light, but the limits of our understanding. Imagine walking into a temple in ancient Alexandria and seeing a statue pour wine without human touch, or watching a miniature theater where mechanical actors perform an entire play powered only by steam and pulleys. These weren't scenes from mythology, they were real inventions crafted by the hands of Greek engineers, whose automata blurred the line between science and spectacle. Long before the age of silicon and circuits, the ancient world buzzed with mechanical marvels that mimicked life itself, offering glimpses into a forgotten era of proto-robotics. At the heart of this tradition was Hero of Alexandria, the same genius behind the steam-powered Aeolipile. His writings describe dozens of automated wonders, from temple doors that swung open magically when priests lit altar fires. Thanks to hidden systems of heated air pressure and counterweights, to singing bird automatons that trilled when water flowed through their intricate piping. One of his most astonishing creations was an entire automated theater, complete with rotating stages, moving scenery, and mechanical actors that performed a tragic play about the wrath of the god Dionysus. Powered by ropes, weights, and rotating drums, the show unfolded with eerie precision, as if guided by invisible hands. But Hero wasn't alone in this mechanical revolution. Centuries earlier, the engineer Philo of Byzantium designed a drinking vessel that refilled itself using clever hydraulics, while Archimedes of Tarentum reportedly built a wooden dove that could flap its wings and fly short distances using compressed air. Even the legendary Daedalus, though shrouded in myth, was said to have crafted statues so lifelike they needed chains to prevent them from wandering away. These stories, whether fully factual or embellished, reveal a culture obsessed with replicating life through machinery. What set Greek automata apart wasn't just their complexity, but their purpose. Unlike modern robots designed for labor or computation, these devices served as religious spectacles, royal entertainments, or philosophical demonstrations. A self-moving statue of a god in a temple wasn't just a trick. It was a bridge between the divine and mortal realms, a tangible manifestation of the god's presence. Similarly, automated theaters weren't mere toys. They were celebrations of human ingenuity, proving that nature's movements could be mimicked and even controlled. The technology behind these creations was shockingly advanced. Heroes' automata used systems of gears, levers, and siphons that wouldn't be rivaled until the Renaissance. Some devices employed mercury or water to create fluid-based logic gates, precursors to modern binary systems. The precision of their craftsmanship suggests a deep understanding of physics, with weights and counterbalances calibrated to the gram. Yet for all their sophistication, these machines remained shackled to the cultural priorities of their time. Without an industrial revolution to propel their development, they stayed curiosities rather than catalysts for broader change. Modern robotics owes an unexpected debt to these ancient experiments. The word robot itself comes from the Czech robota, meaning forced labor, but the concept of artificial movement traces back to the Greek automatos, meaning acting of its own will. In a way, Heroes' steam-powered birds and self-opening temple doors were the first steps toward today's drones and smart appliances. They represent humanity's timeless urge to breathe motion into the inanimate, to blur the boundary between the made and the born. The legacy of Greek automata lingers not just in museums, but in the questions they force us to ask. How different might history be if these inventions had been industrialized? Could the ancient world have stumbled into a mechanical age 2 millennia early? The answer lies buried in the ashes of Alexandria's burned libraries and the silent workshops of forgotten engineers. What remains undeniable is their brilliance, a reminder that innovation isn't linear, and that the seeds of the future often lie scattered in the past, waiting to be rediscovered. Deep in the shadowy vaults of museums and private collections, a handful of crystal skulls stare out with hollow eyes, their origins shrouded in equal parts mystery and controversy. Carved from solid quartz, some as large as human heads, these eerie artifacts first captured public imagination in the late 19th century, when dealers claimed they were ancient Mayan relics imbued with supernatural powers, tools for healing, communication with spirits, or even predicting the future. But here's the twist: while their legend has fueled countless books and even an Indiana Jones movie, the truth behind these skulls is far murkier than any Hollywood script. The most famous specimen, the Mitchell-Hedges skull, surfaced in the 1920s under suspicious circumstances, discovered by adventurer F.A. Mitchell-Hedges during an excavation in Belize. It was later revealed his daughter might have actually purchased it at a London auction. What makes this skull so mesmerizing isn't just its near-perfect symmetry or the way light refracts through its quartz. It's the claim that no modern tools could replicate its precision. Yet when scientists subjected similar skulls to electron microscopy in the 2000s, they found minute markings consistent with 20th century rotary wheels, not ancient hand tools. The verdict: most are elaborate hoaxes, likely crafted in 19th century Germany to feed a booming market for exotic antiquities. But what if a handful of these skulls are genuinely old? A few specimens, like the Smithsonian skull and the British Museum skull, lack clear provenance but exhibit wear patterns suggesting centuries of handling. Indigenous oral traditions from Mesoamerica speak of crystal skulls used in divination rituals, where priests would gaze into them to interpret visions. The Maya revered quartz as a conduit to the spirit world, and their lapidary artisans were masters of stonework. Could they have created skulls as sacred objects? Without irrefutable evidence, the question lingers like a ghost in the archaeological record. The skull's modern allure isn't just about their origins, it's about the human desire to believe in lost wisdom. New Age enthusiasts insist the skulls emit energy fields or store ancient knowledge, theories scientists dismiss as pseudoscience. Yet experiments have shown that quartz can generate piezoelectric charges under pressure, a property the Maya might have associated with magic. Imagine a shaman rubbing a crystal skull during a ceremony, feeling it vibrate subtly in their hands, interpreting the phenomenon as divine communication. Even if the skulls themselves are modern, the beliefs they embody tap into something far older: humanity's timeless fascination with merging technology and the transcendental. Perhaps the greatest lesson of the crystal skulls isn't about their authenticity, but about the stories we project onto the past. They're mirrors reflecting our own obsessions with ancient aliens, forgotten civilizations, or the idea that our ancestors possessed secrets we've yet to rediscover. Whether crafted by 19th century artisans or pre-Columbian priests, these enigmatic objects remind us that history isn't just about facts, but the myths we weave to make sense of the unknown. And in that space between truth and legend, the crystal skulls continue to whisper their riddles, daring us to look deeper. Rising 23 feet above the grounds of Delhi's Qutub Minar complex, the Iron Pillar of India defies one of nature's most relentless forces: corrosion. For over 1,600 years, through monsoons, scorching summers, and the passage of empires, its smooth, inscription-covered surface has refused to rust. Modern scientists have analyzed its metal composition, revealing an astonishing truth. This isn't just iron, but a sophisticated alloy mixed with phosphorus in precise proportions that create a thin, invisible protective film. This self-repairing barrier shields the pillar from oxygen and moisture, a feat of metallurgy so advanced it wouldn't be matched until the 20th century. How did ancient Indian blacksmiths, working centuries before the scientific method, crack the code to near-perfect rust resistance? The answer lies in a forgotten tradition of empirical innovation. Unlike modern steel production, which removes phosphorus as an impurity, the pillar's creators intentionally incorporated it at nearly 1% of the alloy, a deliberate choice that modern replicas have proven drastically reduces corrosion. Analysis of the slag inclusions suggests the iron was smelted using a unique high-temperature process involving charcoal and iron ore rich in phosphorus, likely sourced from the central Indian region of Vidarbha. The craftsmen didn't just stumble upon this formula, they perfected it through generations of trial and observation, passing down knowledge not through textbooks, but through the ringing blows of their hammers. What's even more remarkable is the pillar's original purpose. Inscriptions in Brahmi script reveal it was erected around 400 CE as a victory monument for the Gupta Emperor Chandragupta II, originally standing at a Vishnu temple complex before being moved centuries later. The text, still legible after millennia, boasts of military conquests, but the real triumph is the pillar itself. Imagine the awe of ancient worshippers seeing this towering, unblemished metal column, a symbol of divine permanence in a world of decay. Modern engineers have tried to replicate the pillar's rust-resistant properties, but there's a catch. While the phosphorus-rich alloy resists atmospheric corrosion, it makes the metal more brittle, unsuitable for dynamic loads like bridges or machinery. This suggests the ancient smiths tailored their recipe for a specific, static application, showcasing an intuitive grasp of material science we're only now fully appreciating. The pillar isn't just a relic, it's a masterclass in context-sensitive engineering, proving that ancient innovation wasn't about universal solutions, but about perfecting tools for their precise role. The iron pillar's legacy extends beyond metallurgy. It challenges the colonial-era myth that non-Western societies lacked advanced technological traditions. Recent discoveries of similarly corrosion-resistant iron artifacts across South Asia hint at a broader metallurgical culture, one that might have influenced later developments like Damascus steel. Yet most of this knowledge vanished, possibly lost during periods of political upheaval or as guilds guarded their secrets too closely. Standing before the pillar today, one can't help but wonder, what other breakthroughs did ancient India's workshops produce, now erased by time? The answers might still lie buried, waiting for a curious eye to uncover them. Until then, the pillar remains silent and unchanging, a metallic whisper from a past that knew more than we ever guessed. Among the treasures of ancient China's technological marvels, few are as mechanically ingenious as the south-pointing chariot, a wooden carriage topped with a figurine that always gestured toward the south, no matter how the vehicle turned. Unlike a magnetic compass which aligns with Earth's poles, this device relied purely on gears and precision engineering to maintain its orientation. Historical texts from the 3rd century describe it as a gift from the legendary inventor Ma Jun to the emperor, though some accounts trace its origins even further back to the mythical Yellow Emperor. What makes this chariot extraordinary isn't just its purpose, but the sophisticated differential gear system hidden within its frame, a mechanism so advanced that nothing comparable would appear in the West until the 19th century. The secret lay in its intricate gear train. As the chariot wheels turned, a series of interlocking cogs adjusted the figurine's rotation to counteract the vehicle's movements. If the chariot turned left, the gears rotated the figure right by the same degree, preserving its southern alignment. This wasn't just a clever trick, it was an early application of feedback control, a principle foundational to modern robotics and navigation systems. Recreations based on ancient schematics confirm the design's effectiveness even on winding paths. The pointer remains unwavering. Why such complexity when magnetic compasses existed? The answer might lie in reliability. Early lodestone compasses were prone to interference, especially on metal-laden battlefields where the chariot was said to guide armies through dust clouds or fog. There's also a symbolic dimension. In Chinese cosmology, South represented imperial authority and celestial order. A machine that literally never lost its way could have been as much a propaganda tool as a navigational aid, projecting an image of divine guided inevitability. Yet the chariot's legacy raises provocative questions. Why did this technology vanish after the Han Dynasty, only to be reinvented millennia later in Europe? Some historians speculate that the gear systems were too delicate for mass production, or that their knowledge was confined to elite artisan guilds whose secrets died with them. Others suggest that simpler compasses made the chariot obsolete, but that doesn't explain why later Chinese dynasties celebrated the device in texts while apparently losing the ability to build it. Modern engineers marvel at the chariot's parallels to analog computers, where physical interactions perform calculations without electricity. It's a reminder that innovation isn't always linear. Sometimes brilliance flares and fades, leaving behind echoes that taunt future generations. The south-pointing chariot stands as a testament to a road not taken, a glimpse of an alternate technological history where gears, not silicon, might have powered the information age. Its silent pointer still beckons us to consider how much knowledge slips through the cracks of time, and what else might be waiting to be rediscovered. Standing beneath the Pantheon's massive dome in Rome, it's hard not to feel dwarfed not just by its size but by its endurance. Built nearly 2,000 years ago, this architectural marvel still holds the record for the world's largest unreinforced concrete dome, defying earthquakes, weather, and the passage of empires. The secret lies in the very fabric of its walls, Roman concrete, a material so advanced that modern scientists are only now beginning to decode its mysteries. Unlike today's concrete, which crumbles after decades, Roman structures seem to grow stronger with age. The key to this ancient supermaterial, a recipe that vanished for centuries, buried under the rubble of history. At the heart of this puzzle is a surprising ingredient: volcanic ash. The Romans mixed lime with fine-grained ash from the Pozzuoli region, creating a mortar that could set underwater and resist cracks. But the real genius lay in what happened over time. Microscopic analysis reveals that when seawater seeped into harbor structures like those in ancient Caesarea, it triggered a chemical reaction. The ash and lime formed crystals that filled cracks as they appeared, effectively giving the concrete a self-healing property. Modern concrete, by contrast, relies on steel reinforcements that rust and weaken when exposed to saltwater, making Roman maritime engineering all the more astonishing. Why did such a revolutionary technology disappear? The fall of the Roman Empire fractured the trade networks that supplied key ingredients like pozzolanic ash. Medieval builders, lacking access to these materials, reverted to simpler recipes. But there's a deeper cultural shift at play. Roman engineering wasn't just about materials, it was a system. Master builders passed down knowledge through apprenticeships, and without the empire's infrastructure, that chain of expertise broke. By the Middle Ages, the Pantheon's dome was seen as a relic of lost magic rather than reproducible science. Today, researchers are racing to reverse engineer Roman concrete, not just for its durability but for its environmental benefits. Modern cement production accounts for nearly 8% of global carbon emissions, while the Roman recipe required lower temperatures and recycled materials. Laboratories have even mimicked the ancient method by adding volcanic rock to modern mixes, creating concrete that heals itself when exposed to water. The irony is palpable. The future of sustainable construction might hinge on rediscovering what the Romans knew all along, yet the full recipe remains elusive. Recent studies suggest crushed pottery or animal bones might have been added for extra strength, while others point to the meticulous layering techniques seen in Roman walls. Each discovery peels back another layer of complexity, revealing a material science that balanced artistry with precision. The Pantheon isn't just a monument to the past, it's a challenge to the present, daring us to rebuild what was lost one volcanic crystal at a time. Picture a Byzantine warship cutting through the choppy waters of the Mediterranean, its prow aimed straight at an enemy fleet. Suddenly, a thunderous roar erupts from its deck as a jet of liquid fire arcs through the air, clinging to sails and hulls, igniting everything in its path. This wasn't just any weapon. It was the Greek fire siphon, a pressurized flamethrower so devastating it could turn the tide of battles in seconds. The secret wasn't just the fiery chemical itself, but the engineering marvel that launched it. A complex system of pumps, tubes, and valves that harnessed pressure to spit flames with terrifying precision. How did 7th century engineers, without rubber seals or steel pistons, build a device capable of such controlled combustion? The answer lies in a fusion of ingenuity and secrecy so tight, even today we're piecing together fragments of how it worked. At the heart of the system was a pump mechanism historians believe resembled a giant syringe. Ancient texts describe bronze tubes connected to sealed reservoirs, with operators working hand pumps to build pressure. Some accounts mention bellows or piston-driven designs, while others suggest a dual-chamber system where heated oil and the Greek fire mixture combined just before ejection. The real breakthrough was in the nozzle, an adjustable bronze spout that could widen or narrow the stream, allowing crews to switch between a focused jet for long-range attacks and a scattered spray for close-quarters chaos. Reconstructions show these adjustments would have required precise calibration. Too much pressure and the mixture could ignite prematurely, engulfing the operator. Too little and the flames would sputter harmlessly. What's often overlooked is the logistical brilliance behind the weapon. Greek fire wasn't just mixed on the fly, it was stored in heated, insulated containers to maintain viscosity, then transferred to the siphon's reservoir via ceramic pipes to prevent static sparks. Crews wore asbestos-lined gloves, a material the Byzantines called unquenchable cloth, while copper valves regulated flow with a level of precision that wouldn't be seen again until the Steam Age. The entire system was a masterpiece of ergonomics, designed for rapid deployment even on rocking decks, with fail-safes to prevent catastrophic backfires. But the true genius might have been in the weapon's psychological impact. Historical accounts describe enemy sailors leaping overboard at the mere sight of the siphon's distinctive silhouette on the horizon. The sound alone, a hissing roar as pressurized fuel met flame, was enough to shatter morale. Unlike traditional fire ships, which were unpredictable and slow, the siphon turned Greek fire into a precision instrument of terror. It wasn't just a tool of destruction. It was a tool of deterrence, a technological shadow that kept entire navies at bay for centuries. Why then did this technology vanish? Part of the answer lies in the Byzantine Empire's obsessive secrecy. The formula for Greek fire was a state secret punishable by death, and the siphon's mechanics were known only to a handful of artisans and naval officers. When Constantinople finally fell in 1453, the last custodians of this knowledge may have taken it to their graves. But there's another, darker possibility that the weapon was too effective for its own good. The siphon demanded specialized ships, trained crews, and vast resources, making it unsustainable as the empire crumbled. In the end, the very complexity that made it revolutionary may have sealed its fate. Today, only echoes remain: a few ambiguous diagrams, fragmented descriptions, and the charred timbers of ships that felt its wrath. Yet the siphon's legacy burns bright in modern warfare, from flamethrowers to fuel-air explosives. It stands as a reminder that innovation and destruction have always walked hand in hand, and that some technologies are so potent they can shape history even as they vanish into the flames. Discovered in 1897 near the French village of Coligny, this shattered bronze tablet might not look like much at first, just fragments covered in mysterious markings. But piece it together, and you're staring at one of antiquity's most sophisticated timekeeping devices, the Coligny calendar, a 5-foot-wide mosaic of lunar cycles, solar years, and cryptic symbols that reveals the Celts' mastery of celestial mechanics. Dating back to the 2nd century, this intricate system doesn't just track days. It harmonizes the moon's phases with the sun's journey across the sky, creating a hybrid calendar so precise it rivals the work of medieval monks centuries later. How did a culture often dismissed as barbarian by Rome achieve such astronomical finesse? The calendar's design is a marvel of interlocking cycles. Unlike the purely solar Julian calendar used by Rome, the Coligny system divides the year into 12 lunar months, each alternating between 29 and 30 days. But here's the genius: to sync these moon cycles with the solar year's 365 days, the Celts inserted an extra month every 2.5 years. This intercalary month wasn't arbitrary. It was calculated to keep seasonal festivals like Samhain and Beltane aligned with harvests and solstices. The result: a self-correcting timepiece that balanced celestial observation with agricultural necessity. What's truly astonishing are the markings. Each month is annotated with cryptic abbreviations, MAT for good days, ANM for unlucky ones, suggesting the calendar wasn't just practical but ritualistic. Certain dates align with surviving Celtic myths, like the 3-day gap marking the transition between years, a time when the veil between worlds was said to thin. The bronze itself may hold clues. Metallurgical analysis shows it was cast in sections, hinting at a communal effort where Druids, the Celt scholar priests, collaborated with metalworkers to etch cosmic knowledge into enduring metal. But the calendar's sophistication raises provocative questions. How did the Celts, without telescopes or written records, track celestial events so accurately? Some scholars point to their monumental observatories, stone circles like Stonehenge's lesser-known cousin, the Gaulish site of Villeneuve-Saint-Germain, where alignments match solstice sunrises. Others suggest the Druids' oral traditions encoded astronomical data in poetry, using meter and rhyme as memory aids. The calendar's lunar focus might even reflect a deeper, older tradition. Archaeologist Alexander Marshak proposed that similar tally marks on 15,000-year-old bone fragments hint at a prehistoric timekeeping legacy the Celts inherited. The mystery deepens when you consider the calendar's survival. Recovered from a Roman-era settlement, it bears Latin letters alongside Gaulish words, evidence of cultural fusion under occupation. Yet its math is purely Celtic, resisting Roman standardization. Was this a covert act of resistance, a way to preserve sacred knowledge even as empires rose and fell? The bronze's deliberate breakage before burial suggests ritual decommissioning, as if its keepers chose to retire it rather than let it be corrupted. Modern simulations confirm the calendar's accuracy, but its true legacy lies in what it represents: a bridge between earth and sky, science and spirituality. Unlike the impersonal clocks of today, the Coligny calendar wove time into the fabric of daily life, marking not just seasons but the rhythms of planting, feasting, and worship. It's a reminder that timekeeping wasn't invented to regiment lives, but to harmonize them with the cosmos. And in that harmony, the Celts left us a question: how much wisdom have we lost by severing our bond with the skies? The broken bronze whispers that the answer might still be written in the stars. Buried beneath the rolling hills of Transylvania, 3 small clay tablets whisper secrets from a time before pyramids, before Stonehenge, even before the first cities of Mesopotamia. Discovered in 1961 near the Romanian village of Tartaria, these unassuming artifacts, 2 rectangular and 1 round, bear strange, crudely etched symbols, spirals, zigzags, and figures that some researchers believe could rewrite the history of human communication. Carbon dated to around 5,300 BCE, they predate the earliest known Sumerian cuneiform by nearly 2,000 years. But here's the twist: no one can agree whether these markings represent sacred symbols, primitive accounting, or the world's oldest undeciphered script. The mystery of the Tartaria tablets isn't just about what they say, it's about what they mean for our understanding of civilization itself. At first glance, the tablet's symbols resemble those found at other Neolithic sites across the Balkans, like the Vinča culture's pottery markings. But the Tartaria tablets stand apart. Their signs are more densely clustered, with repeating sequences that hint at structured meaning rather than random decoration. One tablet shows a horned animal alongside a series of lines and dots, while another features a grid-like pattern eerily reminiscent of later Sumerian accounting tablets. The most controversial is the round tablet, pierced with a hole and inscribed with spirals radiating outward, a design some interpret as a cosmic map or ritual calendar. The debate rages: are these the precursors to writing or simply elaborate ritual objects? What fuels the controversy is their potential connection to a broader Danube script hypothesis. Over 2,000 similar symbols have been found scattered across southeastern Europe, dating from 5,500 to 4,500 BCE. Unlike pictographs, which directly represent objects, these signs appear abstract crosses, combs, branching lines suggesting they might encode phonetic or symbolic information. Linguists remain divided. Some, like the late marriage gimbuters, argued they represent an early form of goddess worship symbolism, while others see them as proto-writing, a bridge between simple tallies and true scripts. The Tartaria tablets could be the Rosetta Stone of this lost system. If only we could read them. Modern technology has peeled back some layers of the mystery. High-resolution scans reveal the tablets were etched while the clay was still wet, then fired at low temperatures, possibly during ritual burnings. Residue analysis uncovered traces of wheat and barley, hinting at use in agricultural ceremonies. Yet the biggest breakthrough might come from an unexpected source: artificial intelligence. Recent algorithmic studies comparing the symbols to other ancient scripts found faint statistical similarities to linear and even Indus Valley glyphs, raising the possibility of a vast, interconnected network of early symbolic communication stretching from the Aegean to the Indus. But skepticism lingers. Without a bilingual text or longer inscriptions, the tablets might forever resist decoding. Some archaeologists dismiss them as personal totems or clan markings, noting that true writing requires consistent grammar and context elements absent here. Yet the very existence of such debate underscores their significance. If these are just random scratches, why do they cluster in specific patterns across hundreds of miles and centuries? Why do later Sumerian and Egyptian symbols bear uncanny resemblances? The Tartaria tablets challenge our deepest assumptions about where and how writing began. For decades, scholars believed writing emerged solely in urban centers like Uruk, born from bureaucratic needs. But these tablets come from a village society, suggesting symbolic communication might have roots in ritual or astronomy rather than commerce. They force us to reconsider writing not as a singular invention, but as a slow crystallization of marks into meaning, a process that might have flickered to life in multiple places before one version caught fire. Standing before these tiny tablets in a Bucharest museum, one can't help but feel the weight of their silence. They might be sacred objects, accounting tools, or something beyond our current understanding. But their true power lies in the questions they ignite. How much of humanity's early brilliance has been lost to time, and what other surprises still lie buried, waiting to shake the foundations of history? The Tartaria tablets don't just predate writing, they predate our very idea of what writing could be. From the Antikythera Mechanism's celestial gears to the Tartaria tablets' cryptic symbols, these 24 ancient wonders force us to rewrite the story of human innovation. They aren't just artifacts, they're time capsules of brilliance, each one a defiant crack in the conventional narrative that paints history as a straight line from primitive to advanced. Take the Baghdad Battery, a clay jar that hums with the ghost of electricity 2 millennia before Volta, or the Nimrud Lens, a polished crystal that bends light like a modern optic. These aren't accidents, they're evidence of systematic exploration, of minds as sharp as ours probing the boundaries of physics and engineering. But here's the unsettling truth lurking beneath these discoveries. How much have we lost? the Greek fire siphon's pressurized flames, and the Roman dodecahedron's geometric perfection didn't emerge in isolation. They were born from cultures that nurtured experimentation. The Mayan crystal skulls, whether ancient or modern hoaxes, speak to a fascination with optics and resonance that mirrors our own laser technologies. And the Dendera Light's eerie bulb-like hieroglyphs, they might not prove the Egyptians had electricity, but they certainly suggest a symbolic or even practical understanding of energy that we're only now beginning to decode. This raises a darker question. Was this knowledge merely forgotten, or was it erased? Historians have long noted how libraries like Alexandria's burned, taking untold volumes of technical wisdom with them. The precision of the Indian iron pillars' rust-resistant alloy hints at metallurgical traditions that vanished with their guilds. Even the Viking Sunstone, dismissed as myth until modern experiments proved its efficacy, reminds us that oral cultures could safeguard advanced concepts without leaving blueprints behind. The past isn't just incomplete, it's been edited, sometimes by time, sometimes by conquest. Yet for all these gaps, the most thrilling realization is how much remains to be found. New technologies are breathing life into old mysteries. Multispectral imaging revealing faded inks on the Voynich Manuscript, AI parsing the Phaistos Disc spirals for linguistic patterns. Every year, archaeologists unearth relics that defy expectations, like the 2,000-year-old Chinese seismoscope, once thought legendary until its mechanisms were reconstructed and proven viable. The stone spheres of Costa Rica and the Olmec compass stones whisper of entire scientific traditions that flourished outside the Eurocentric canon. What ties these fragments together isn't just their sophistication, but their shared lesson: innovation isn't linear. Civilizations rise, fall, and sometimes rediscover what others already knew. The hero's steam engine didn't spark an industrial revolution, but it proved the principles were graspable far earlier than we assumed. The Tartaria tablets may never be deciphered, but their very existence suggests that the urge to encode knowledge in symbols is as old as agriculture itself. So where does this leave us? Not at an ending, but at a threshold. Every museum vault, every newly scanned manuscript, every trench dug in some overlooked ruin could hold the next Antikythera, a device that appends our assumptions once more. The real magic of these artifacts isn't just what they tell us about the past, it's how they reframe our future. If ancient minds could leap this far, what does that say about the potential still locked within our own? The search for answers isn't just about rewriting history, it's about rediscovering the boundless creativity that makes us human. And that journey, much like the artifacts themselves, is only just beginning to unfold.